What if the machines we built to serve us become smarter than us? On this channel, my goal is to help you make sense of a world being rewritten by AI and automation. Now, if we want to understand where AI will take us in the future, we also need to understand where it came from. So today, we're going to go back to where it all began, from before computers even existed, to Alan Turing's thought experiments, to the machine that wrote this very sentence. This is the history of the fundamental question, can machines think? And the answer may seem obvious now, but until recently, it really wasn't. I hope you enjoy. So, where did the idea of computers even come from? So, for most of human history, humans were the computers. Being a computer was actually a job where humans were hired to manually calculate things like compute logarithms, trigonometric functions, and planetary positions, endlessly, day after day. As you can imagine, it was slow, repetitive, and full of errors. Then, in the 1830s, English polymath Charles Babbage asked a radical question. What if a machine could do math step by step on its own? He designed the analytical engine, a giant steampunk-like gear-driven calculator that could be programmed to do different calculations automatically in a specific order based on instructions. Now, unfortunately, it was never built, but it was the first real blueprint for a programmable computer. And for that, Babbage is remembered as being the father of the computer. Now, after Babbage, computing ideas evolved slowly, but early computers were often seen as expensive toys or scientific curiosities for math, but not practical tools, until war changed everything. In 1941, German engineer Konrad Zuse built the Z3, the world's first programmable automatic digital computer. It was used for aircraft design calculations during World War II. Then, in 1945, the Americans unveiled ENIAC, the first fully electronic general-purpose computer. It was designed to calculate artillery firing tables. What used to take 40 hours by hand, ENIAC could now do in 15 minutes. War had made computers practical strategic tools that could save time, resources, and lives. Now, up until this point, computers have essentially just been big, powerful calculators the size of buildings or rooms. But the concept of a thinking machine started with Alan Turing. In 1950, Turing wrote a groundbreaking paper called Computing Machinery and Intelligence. In it, he opens with the famous question, can machines think? Now, he didn't mean it philosophically, but practically. He proposed a simple test, later called the Turing test. If a machine could convincingly imitate human conversations, it could be considered intelligent. Now, he wasn't asking if the machines have consciousness or feelings or a soul. He was simply asking, can a machine act like it's thinking well enough to convince a human? And although not perfect, it was one of the first serious attempts to define machine intelligence in observable terms. Now, around the same time, another pioneer named Arthur Samuel was laying the groundwork for something different. Machines that could learn from experience. In the 1950s, Samuel built a self-learning checkers program at IBM that improved by playing games against itself. He coined the term machine learning in 1959, defining it as computers learning without being explicitly programmed. Now, the 1960s and early 70s were a golden age of AI optimism. Researchers believed that human-level intelligence was just around the corner. Now, AI was mostly symbolic at the time, based on logic, rules, and structured language. Early programs like Logic Theorist and ELIZA, while very basic by today's standards, dazzled with their ability to solve puzzles, hold conversations, or manipulate virtual worlds using natural language. Pioneers like Marvin Minsky boldly predicted that the problem of artificial intelligence would be solved within a generation. It was a period of great investment by the military and government. Labs across the US raced to build machines that could reason, translate languages, and understand speech. But behind the scenes, these systems struggled with complexity and lacked common sense. Now, the 70s brought a wave of disillusionment. Early AI systems couldn't handle the complexity of the real world. Translation programs failed, logic-based systems couldn't scale, and funding dried up. This era became known as the first AI winter, a time when AI was considered to be a dead end. Ironically, while AI stalled, the personal computer revolution exploded. Microprocessors, pioneered in the early 70s, led to a wave of innovation. Apple, IBM, and Microsoft brought powerful computers into homes and businesses, and processing power grew exponentially. This new computing power quietly laid the foundation for AI's return. In 1986, Geoffrey Hinton, remember this guy, helped reignite the field with a breakthrough: backpropagation. This allowed neural networks to learn from mistakes, which was a major leap in machine learning. So how does backpropagation work? So it's like a student taking a test, checking the answers, and then adjusting their study strategy each time to score higher. Backpropagation lets the machine look at how wrong it was, trace that error back, and tweak the connections inside. Now, AI could improve itself using data, not just rules, but where to find the data. This was followed by another shorter AI winter in the 1990s, but in 1997, a monumental event happened. IBM's Deep Blue shocked the world by beating world chess champion Garry Kasparov. This was previously thought to be impossible, and it rekindled the public's interest in AI. The 2000s marked a turning point. The growth of the internet would see the rise of current behemoths, Google, Facebook, and YouTube. The internet, social media, smartphones, and humanity started generating more data than ever before. And for the first time, machines had enough raw material to learn at scale. Traditional AI systems couldn't keep up, but machine learning thrived on data. Algorithms began spotting patterns in ways that mimicked how humans learn. By example, not just by rules. One key breakthrough was the development of convolutional neural networks, neural nets inspired by the human visual system. These networks were especially good at analyzing images and laid the foundation for modern computing vision. In 2007, the launch of ImageNet supercharged this progress. It was a massive open database of millions of labeled images designed to challenge researchers to build smarter image recognition models. It was basically like an AI Olympics, and it pushed the field forward fast. Meanwhile, faster processors, cheaper storage, and the rise of cloud computing made it possible to train more complex models. Suddenly, AI had the fuel and the engine to evolve. Big data didn't just boost AI, it transformed it. It turned narrow programs into learning machines and prepared the ground for the breakthrough of the next decade. In 2012, everything changed. A team led by Geoffrey Hinton, this guy again, entered the ImageNet competition with AlexNet, a deep convolutional neural network. Now, it didn't just win, it crushed the competition, cutting the error rate in half. This is the moment that marked the big bang of modern AI, and for its contributions to the field, Geoffrey Hinton is actually now known as the godfather of AI. Now, fueled by big data, better algorithms, and exponential computing power, AI entered into a golden era of rapid progress. Google acquired DeepMind and trained AI agents to play complex games like Go and StarCraft. NVIDIA started shifting focus to building GPUs for AI, supercharging model training. All the tech giants raced to apply deep learning to everything: translation, speech, vision, and recommendation engines. Now, at the time, Google's dominance in AI raised concerns about centralization. In response, Elon Musk, Peter Thiel, Sam Altman, and others founded OpenAI in 2015, with the goal of making AI research open and beneficial to humanity. And then the biggest leap came in 2017 when Google researchers introduced the Transformer model, an architecture that revolutionized how machines understood language. So transformers are like language engines that read not just word by word, but all at once, seeing the entire structure of a sentence, like a chess master who sees the whole board in one glance. It's this technology that OpenAI quickly adopted to create a generative, pre-trained transformer that could write, summarize, answer, and chat like a human, ChatGPT. What made ChatGPT truly revolutionary is that it was the first form of artificial intelligence that could mimic human language at scale with fluency and coherence. For the first time, we have an AI that can understand context, nuance, tone, and think. Released in 2022, ChatGPT hit 100 million users in just 2 months, making it the fastest growing app of all time. So, we're now in the age of AI. In just 10 years, AI has gone from a niche lab experiment to a world-changing platform. Beyond ChatGPT, platforms like Midjourney, Stability AI, and 11 Labs enabled anybody to generate realistic images, voices, or text from simple prompts. We're actually entering an era in which we don't know that if anything we see is real. Annual investments now exceed $40 billion. From writing code and generating music to diagnosing diseases and driving cars, AI is no longer confined to labs or novelty apps. It's infiltrating every industry and every part of society. Machines write, paint, speak, and even reason. We are far beyond what Turing originally theorized. But with that power comes big questions. What happens to jobs? Who controls the tech? And how do we ensure it benefits everybody? So, this story started with a question from Turing. Can machines think? Today, maybe the better question is, what happens now that they can? How far will they go? And are humans even needed anymore? So, if you found this journey fascinating, hit subscribe. This is just the beginning of how AI will shape our future. Stay useful, and we'll see you in the next video.